In this tutorial, we'll create a roller coaster using multiple generators to add the different parts, including a pipe and frame that attaches a rail to the main structure and can be banked using markers applied to the spline, of course the train itself, and finally the supporting scaffolding which reaches from the top of the roller coaster to ground level. This is an advanced tutorial, so if you are new to RailClone, I'd certainly start with one of the earlier episodes in this course. As always, before we start building the style, we'll take a quick look at the source geometry. You can also download the starter file from the website if you want to follow along. Here are the pieces. We have two carriages, a start and a repeating midsection, the rail on which they sit, a pipe and an evenly part of that pipe below that. The pivots have been organised so that when they're rotated, the rail and the carriages share a common point. This will make sure that when they bank, they stay attached. So now let's create the first array to add the rail. Create a new RailClone object and open the style editor. Add a new linear generator and then the spline. Wire it to the spline input and pick a path from the scene. Create a segment and then import the rail geometry, wire it to the default input. And that's a pretty good start. We've now got the rail following the spline and it's using the spline's default banking at the moment. We'll change the alignment to pivot to make sure we use that pivot that we mentioned a minute ago. To control the banking, we'll pick the base spline and add a RailClone spline modifier. If you go to the sub-objects, you can see there's a banking section, and if we go down to the interface, there's a rollout for banking. All that you need to do is click on the Create button and click on the spline anywhere you want to add a banking marker. These are a little bit small to see from this distance, so we can increase them using the gizmo size property. Just pick these from the scene in the sub-object mode, change the alignment type to local, and you can see you can easily control the banking just by rotating these gizmos. While we're here, let's turn on Use Segment Material so that we can pick the materials off the source geometry and then increase the curve step so that the deformation is a little bit smoother. Now let's move on and add the train itself. So we'll add a new linear generator and use the same spline. Wire in a segment, pick the carriage from the scene. Now let's bring in another segment and we'll pick the front of the train from the scene. Create a new sequence operator, wire in the carriage first of all and then the train front. Wire this to the default input. I'm just going to change the mode to claim so we can see the geometry a little bit clearer. And here we can see, of course, that the train isn't sticking to the rails the way we would expect, and that's because I haven't yet set the pivot. So I'll select both the carriage and the front of the train section and go to Alignment Z and change them to pivot. That's much better now the wheels are sitting on the railing. We want to stop this train from extending through the full length of the spline. I'm going to do this using a null segment, and that's basically a segment that has no geometry attached. Anytime you attach one of these to the end of a sequence operator, it basically kills the array at that point. Oops, you can see I've got the geometry the wrong way around, so I'm just going to use a mirror operator to flip it. The train is obviously at the beginning of the spline. What if we want to move it along? You can do that with another null segment, so just wire that to the start of the sequence, and then by increasing the fixed size, we can move the train along the spline. Like so. Of course, this train is a little bit too short, so if we want more carriages, we can just increase the count value in the sequence operator. Here I'm entering a value of 10. So far, so good. If we want to be able to adjust those from outside the graph, we can export the properties and then we can add numeric nodes to control them from the modifier panel. So here I'm going to add a new numeric node, change it to scene units, and of course give it a name so I know what it is. I'm going to call this one train position. Wire it to the exported X fixed size value. Now if I come over to the modify panel in the parameters rollout, you can see that I can control the position of the train directly from that panel. This is great for styles like this that are going to get complex and you don't necessarily want people to have to understand how the graph works. We can do the same thing for the counter for the train, so I'll export that from the sequence operator, wire in a new numeric node, leave it at integer, and you can see it's automatically picked up the name, so I don't need to change it. Now I can control the number of carriages directly from the modify panel. Let's keep going. Underneath the rail, we're going to have this connecting pipe and some evenly segments that will attach it to the scaffolding. So to add those, we'll add a new linear generator, and of course we'll use the same spline again. I'm going to add a segment, and then I'm going to import the pipe from the scene and wire it to the default input. I'm going to do the same thing for the bracket. So we'll pick that from the scene and wire it to the evenly input. Let's change the alignment Z to pivot for both those segments, and then just temporarily turn off the train and the track so that we can see a little more clearly what's going on. First of all, it's following the banking, and we don't want it to do that. To get rid of that, go into the generator's rules, go down to banking section and set the modifier value to 0. That way you'll basically turn off banking for that object. We also want to change the evenly segments, so we'll change them to 200 centimeters between the centers and then change the mode to adaptive. We'll do the same thing for all of the evenly settings for all of the generators. Now, I want these to remain upright, and one way to do that would be to change it to vertical mode, but as you can see it deforms the geometry in a slightly odd way, which I don't want in this particular case. So what I'm going to do instead is leave it on adaptive, and I'm going to override even the built-in banking that's applied to the spline by default just by putting a transform node after the segment and turning on override banking / X rotation, and just leave the value at 0. Now what I'll get is segments that remain perfectly upright without any deformation on the verticals. That works well in this case. I'm also going to change the default mode to scale just to minimize the amount of slicing that goes on between these evenly segments. It just makes it a little bit more efficient. Then just change the Z rotation because I want this to sit on top of some pipes that are going to be underneath it, and they're going to butt up right underneath that spline, so I want to move the top down. But okay, so you can see the track and the train aren't going to sit on that properly now, so what I need to do is move those up. So I'll just go into the generators for these, and I'll just increase the Z offset. 50 centimeters is about right for this style. So this is working well. I've got the connecting rail at the bottom, I've got tracks that's sitting on top of that, and then I've got the train that's sat on top of the tracks. Next up, we want to start to add the scaffolding underneath, and this will reach down from the bottom of the spline to the ground. We'll start with the very top of the scaffold, which uses its own generator. So we'll just turn off the existing generators to start with, just so we can see a bit more clearly what's going on. And then I'm going to add a new linear generator just for the top, once again using the same spline. Add a segment node, and I'm going to pick this piece of geometry from the scene and wire it to the default input. Once again, it's following the banking we applied using the RailClone spline modifier, which we don't want it to do. So I'm going to come down and turn off banking again from the Rules tab. Get rid of the banking that's automatically on the spline by overriding it using a transform node. I'm also going to set the default mode to scale, and I'm going to change the evenly setting to 200 centimeters and adaptive, the same as the previous generator. Of course, that doesn't do anything because I've got nothing in the evenly input, so I'm going to wire a null segment to the evenly input. It doesn't add any geometry, but it forces the default segments to only be 200 centimeters long, and it's going to fit them together nicely with the rest of the geometry. After that, I'm going to add the rest of the scaffolding, which comprises of 3 different parts, which are nested arrays. There's 1 for the evenly column, and there's 2 for variations of the braces, which will go in the default. To achieve it, there will be nesting generators and using expressions which will find the height between the top of the roller coaster and the ground. But before we get into that part, let's create the 3 generators we're going to nest, starting with the evenly. Create a new generator and wire in another segment. I'm going to pick the same piece of geometry and wire it to the default input. And there you can see we have created at the RailClone origin a simple generator using the XSize property to set the dimensions. Now if we wire in the end of this generator, this tube here, and wire that to the end input. If we're getting kind of close, you can see the open end, so we want to just overlap those a little bit. So we can do that by going to the segment and putting a negative value in the left padding. Just closes that gap up. So that gives us the geometry we're going to use for our evenly input in the final scaffold. One thing though is that at the top, we don't really want that cross section to be sliced. So I'm going to use a macro called scale final segment. And it does pretty much what it says. It's going to see the final segment and then it's going to scale it to fit the space. You wire in the default geometry and then the end geometry, and then you can set a size, a minimum size that you'd like the last object to be. At the moment you can see it's far too large, so we'll reduce that to about 125 centimeters. Now if I change the size, you can see the last segment is always slightly rescaling to make sure it fits. The reason I'm doing this is to make sure that the rest of the brace is not the last one, but the rest of them line up with the rest of the scaffold. If I used adaptive mode, then none of the rows would line up with one another, and it would all look a little bit unnatural. Now we're going to add one of the default segments, so we'll create another generator, and I'll create another segment, and pick one of these default pieces of geometry from the scene. Wire it to the default input, and then set the size to, for now, 20 meters. So that's easy enough. And then to create the other one, we'll just copy and paste that and swap the geometry. So now we've got another generator, and I'll just swap the geometry. I've got 3 different 20-meter lengths ready to go. I'm going to turn off the remaining generators so that we can see much more clearly what we're about to do as we nest this array. I'm going to create another linear generator, and once again use the same spline. Wire the evenly part into the evenly input. You can see immediately it's added it to the spline, but of course this geometry is laying down flat, so it's going along the length of the X-spline. We want it to be vertical. So a few things. We want to turn off the banking, of course. So that will stop it following the banking. To rotate the geometry so that it's vertical, we'll add a transform node and go into the transform's fixed rotation and use a value of minus 90 degrees for the X-axis. Now you can see that's working great, but it's sort of splaying out like a fan rather than staying stepped. So we'll go into override deform and change the mode to stepped. Also turned off slice here. Okay, so we can see that's working. We've got our evenly segments. Of course, we've got the wrong spacing on them. So just to match everything else we've done, I'll turn on adaptive mode and change the distance to 200 centimeters. All good. Going to wire this to the start and the end inputs. Now we want to bring in the default to fill in the gaps in between. So I'm going to do this using a sequence operator to create a pattern and then wire them to the default input. Just like before, as you can see, this geometry is laying flat at the moment, so we need to turn it around. So we'll come into override deform, change the mode to stepped. And then of course coming to the transform, and I'm going to set the rotation to 90 degrees. And I'm going to set the Z rotation to 180. This will get it to stand up correctly in between. That's working great. Of course, it's being sort of sliced at the moment, so set the default mode to scale. But of course, they're above the spline, and we want them to be below the spline. So how do we fix that? Well, we're going to use an expression that can access the Z position of each segment where it sits on the base spline. And since we want to do that for the spline that's attached to a specific generator, to make it easier to find, I'm going to rename it. In fact, I'm going to call it Scaffold. Now I'm going to come into each of the nested generators. I'm going to export the X size, since that's a property I want to affect with this new value we're about to create. I'm also going to export the fixed translation Z property of the 2 transform nodes. That will allow me to move those nested generators down on the Z axis. Now I need to calculate the value that I'm going to use for these. So I'm going to add an arithmetic node. I'm going to change the mode to expression. I'm going to choose Edit Expression. Now, on the left-hand side here, you can see all of the attributes that we've got available. If I scroll to the bottom, you can see, well, it stops there. So all I've got access to at the moment is the attributes of whatever I'm about to wire it to, but I want to access attributes of another generator further down the chain. When I wire this to the X size input of these nested generators, now on the left-hand side, you can see at the bottom here, I've got access to specific generator names. And we know from renaming it earlier that I want to access Scaffold. So I'll click on that. And in here, I've got a list of all the attributes. I want X-spline chords. So I'll type return to tell the expression to return the following value. I'm going to put scaffold X-spline coordinates .z. Basically, I'm asking it to return the distance between the RailClone pivot and the segment's position on the Z-axis in this case. And that's the value I'm outputting. Click OK. So now, what I'm getting now is that each one of these different nested generators is now filling the size of the gap between the spline and the ground. But of course, they're still above the spline. I want them below the spline. So what I need to do is take that value and reverse it, make it a negative. And I'm using a macro called negate value for that. You could just multiply it by -1, but this does it for you. And I'll wire that to the Z fixed translation input. And now you can see the scaffolding is the right height and it starts below the spline. Looks like I've got a rotation property wrong somewhere. So I'll just change this rotation to 90 degrees to make sure that the rows line up correctly, and now you can see that they do. Now we have our basic scaffold. But if I get in a little bit closer, you can see there's a bit of an issue where the way that they're sliced, because they're sliced flat and the spline is at an angle, they're actually sticking up above the spline level. There's no way I can cut these at an angle. The best thing I can do is just to remove the last section to make sure it's a little bit shorter and it comes in underneath the spline. In order to do that, I'll need to slightly edit the expression just for those default nested generators. So what I'll do is I'll bring in another arithmetic node. I'm not going to edit the original one since that needs to stay the same. And I'm going to export the size of one of the segments so I can use it in my calculations, the X size. So now, as I said, I'll bring in an arithmetic node. I'll wire it to the two default nested generators. And then in input 1 of that node, I'll take the current height that we know from the previous expression and the X size into the second input. Now I can use those two attributes in my expression just by typing either input 1 or input 2. So I'm going to type return. And then I'm going to use a function. I'm going to use floor. What that basically does is it takes the result of whatever I put after it and it rounds it down to the nearest whole value. So I'm going to take the height, which we know, which is input 1, and I'm going to divide that by the size of one segment piece. So that will tell me how many whole segments will fit into that height. So now I've got that value. If I multiply that by the size of one of those segments, then that will give me the size of the array that includes only whole segments. So I multiply that by input 2. Use a semicolon to close the line and hit evaluate. And now you can see we've only got whole segments. There's no slicing. You can see it still isn't perfect because X-spline chords.z is calculated at the point at which this is inserted, and that's right next to the evenly input. And that means that although on the left-hand side here, for example, the height is correct, by the end of that segment, it's still overlapping the spline. So what I need to do is just to slightly adjust the length, basically make it a little bit shorter, and then calculate how many segments will fit into it. And I'm going to do it basically by half the size of one of these segments. So I'm just going to modify my expression a little bit. Add another bracket, so I'm doing a calculation before we divide it. And then I'm going to minus input 2 divided by 2. So the size of one of those segments in half, and minus that from the overall height, and then divide it by the size of the segments to get a total number of whole segments that will fit in there. Now you can see that's working really well. There's nothing sticking out on top of the spline, and it's not stopping too far from the top either. Now all that remains is just to turn back on the other generators, and we have our completed roller coaster style. Of course, so I'm just going to go into boxes to make this much faster to update, and then we can see that the whole thing is manipulated just by going into the base spline and controlling the vertices, just moving them up and down. And of course, to get the twist in the actual track, we can just go into our RailClone spline modifier and modify those banking markers. We can apply it to a much larger spline just by coming into the base objects rollout and assigning a much larger spline. And since we exported the parameters, we can frame the camera view, and then we can tweak the position of the train and the number of carriages without having to open the style editor. I hope you enjoyed this tutorial and learned some new skills. So this is probably our most advanced tutorial in this series so far, and there's lots to take in there. We've covered some really important settings. We've demonstrated how to use RailClone markers for banking. We've also looked at how to nest generators, and then how to access the properties of generators using expressions. In the next tutorial, we'll learn how we can export this geometry using a RailClone proxy mesh and import it into another scene. We'll also look at how the proxy mesh can dramatically speed up your build times to improve the speed of file handling and launching a render.